Hello students, welcome back to the Prelims Masterclass wherein we are covering your current affairs section. So I'm dealing with the science and technology portion, and till now we have completed substantial portion of this current affairs part, and that too we are doing it in a theme wise manner so that we get complete clarity of one particular theme. Now in the last lecture I started discussing about health and diseases part. Okay, we covered some of the topics. Today, I'll be completing that section first. So, few more topics, few more articles are still remaining. We'll complete that part. After that, we'll head towards other topics. Let's say there's one theme called IT and computers or the communication part. So, whatever technologies are being discussed, we will continue over there and we'll complete that segment. After that, there are some topics which I can call as miscellaneous topics. Miscellaneous, as in we can't categorize them in any particular theme as such, but still they are relevant from exams perspective. Okay, so some part will be like science and technology in everyday life, and some part completely miscellaneous. Okay, so we will discuss all of that. Okay, so let me check if we have any comments before we start. Okay, no comments. Fine then. So let's start with our first topic. Okay. Yeah, no, before that, the notification from Narayana's Academy about admissions that are 1 year as well as 2 year courses are active. If you want to take admission or if you just want to know about these courses in detail, you can reach out to our website. There you will find all the details regarding our 1 year and 2 year course. You can reach out through that QR code which is being shown to you through the screen, or else you can click on the links provided in the description box. Okay, so moving ahead, I'm continuing the health and diseases part. Okay, so I'm continuing this segment. Now, here, first of all, we will try to look at something called silicosis. Now, this is something very interesting. Silicosis, the term is coming from silica. And recently there was a news which said that there are rising cases among mine and construction workers in terms of silicosis. So many construction workers, they are complaining that they are getting a special disease called silicosis. Now we are interested in knowing what is this disease exactly, why it is being caused, what's the exact cause behind it, and why only construction workers are getting this kind of problem, or people working in the mining industry, they are getting this problem. So you see, it's a respiratory lung disease and it's a progressive disease. With time, it is going to become a very dangerous disease for your body, for this respiratory tract. Now, how this is caused or why a person faces this particular problem is because of something called silica. Or to be more specific, it is SiO2. Now, when a person inhales SiO2, or simply to say the silica element, and this person is inhaling this part continuously, let's say every day this person is inhaling it. So, because of this SiO2, this person's lungs will get affected. They will start solidifying. Now, where do we find this SiO2? We find it in sand, rocks, quartz, etc. Now that's the reason people who are working in the construction industry, or they are working in quarrying, manufacturing, pottery, dentistry, mining, etc., they are usually exposed to sand, rock, quartz, all these materials. And that's the reason this silica or this SiO2, they are inhaling it. Okay. Now when it enters your lungs, That too for a long duration, persistence is there. In that case, your lungs will start hardening because of this silica dust. So this, the property of silica gets entered, or gets attached to the lungs, and that's the reason your lungs are becoming solid, little bit solid, or rather becoming hard. Okay, so obviously some kind of disease related to your lungs that you're definitely going to get because of silicosis or this silica. Okay, now what kind of symptoms a person shows when he or she is affected with something called silicosis? So he or she will show persistent cough, shortness of breath, some fever. The skin will become little bit bluish, and long term risks include lung cancer, pneumoconiosis, TB, or any other respiratory diseases. So all the respiratory tract, this what we call as bronchitis, disease called bronchitis or pneumonia, TB, all these are related to your respiratory tract or your lungs. So all such diseases can be there as a result of silicosis in future. Okay. Now, can we detect? Well, it's very difficult to detect silica and all because it's a dust particle, right? It is odorless, it is non-irritating, and it causes symptoms in a delayed manner. It will take a long time for you to know that you have got silicosis. That's the reason detecting silicosis is a problematic stuff, is what we can say. Now, we have seen patients in different stages. Some are having acute problem. After some time of in few people we have seen accelerated stage. So let's say they have been inhaling this silica for last 10 years. So they will show this accelerated stage. And people who are exposed to this silica for a very long duration, let's say 10 to 30 years, now that's a chronic stage and that's a very dangerous state. Okay. Now, there are some regions which are very much vulnerable. Especially these are the regions where we find many resources. These are states full of resources. That's the reason there you see mining activities or such activities because of which these workers get affected more. So, for example, you have Odisha, Chhattisgarh, Bihar, Jharkhand, Gujarat, Rajasthan. Okay, these are the states where we see these workers get affected more. Now, do we have any treatment for silicosis? The answer is no. There is no real treatment, there is no final cure as such. What max you can do is you can try to prevent this disease. You can use some mask, you can use something so that this silica you don't inhale this part. And if you come to know about this disease earlier, you can take some preventive measures there also. Okay, but we don't have any cure as such. It's an irreversible disease is what we can say. Okay. Now, one more thing you need to know about the silicosis specifically is it has got some legal status. So we have this act called Factories Act 1948. In that Factories Act, they have third schedule. In that schedule, this silicosis has been mentioned or has been notified. Okay, so this you should remember. Even this Mines Act 1952, that act also mentions this particular disease. Okay, so this legal status part you must be aware of. Clear? This was our first topic and a very easy topic. Okay, health and diseases segment is very easy, very factual. At least you should know the cause behind a particular disease. You should know whether there is a treatment available or not. So this is the basic part you must be aware of. Okay, now see, another one or another article is related to something called, or in short, you must have heard about this disease called mpox or monkeypox. Now, this disease was in news. It was in news because World Health Organization declared that this mpox is a public health emergency of international concern. Now this is something interesting. It's not like WHO is going to call any disease or any kind of a spreading disease as public health emergency of international concern. Last time we heard this terminology when there was COVID-19, which was spreading throughout the world in the form of a pandemic. So only such serious stuffs, only such seriously spreading disease, which has some fatality rate or which is going to cause damage to the health throughout the world. Such diseases are considered by WHO to be listed under this category. Okay. So the news says that WHO has declared mpox or monkeypox as this public health emergency of international concern. And they saw the outbreak of this disease in Democratic Republic of Congo. So they observed that it is spreading from Democratic Republic of Congo, then throughout the Africa. They were observing the way it was getting spread, that made it something we call as of international concern. International community should be concerned about this particular disease. Okay, now see, let's try to understand monkeypox disease. First of all, it is caused by a virus. Its name is called as viral zoonotic disease. Zoonotic, whenever we use this term zoonotic disease, that means a disease is getting spread or getting transmitted from a animal to a human being. So let's say something coming from bat, then to human beings, then that would be a zoonotic disease. Okay, and here we are calling it a viral zoonotic disease. That means that it is caused by a virus. The name of that virus is monkeypox virus. You can remember it very easily, right? Now, if you check the type of this virus, it's a DNA virus. In the last lecture, I discussed this part. When you look at virus is neither a living being nor a non-living being. If you observe virus like this, let's say I have virus over here, then it is a non-living being. But when it enters in my body, when it gets a host cell or host organism, in that case it starts performing or behaving like a living being. And this virus could be made up of just DNA, could be made up of just RNA, anything is possible. Here we are saying it is a DNA virus. And the family to which this virus, monkeypox virus, belongs to is Poxviridae. Okay, this is the scientific name of this family. You should know. Now, if you check the history, for the first time, this monkeypox virus, it was identified in 1958 in monkeys. That's the reason we gave it the name called monkeypox. And in 1970, for the first time, we saw a human case in the same country, that is Democratic Republic of Congo. Okay. Now see, this mpox or this monkeypox, when we look at this virus is also of different types. We call those types as clades. So there's clade 1, there's clade 2. Clade 1 is common or is getting spread in Central Africa. And the second one, clade 2, is common in Western Africa. And if you see the difference between these two viruses or these two clades, the clade 1 seems to be very severe. It's very dangerous as compared to clade 2, which is getting spreaded in the Western Africa part. Okay, it is relatively milder as compared to clade 1. Now, what kind of symptoms you get when you are affected with monkeypox virus? First of all, there will be some skin rashes or mucosal lesions. So some lesions like some kind of lumps or bumps there will be on your hand or let's say on your body. That will be there and it will be in progression. So slowly they will start increasing. Then you might get some fever also and some symptoms just like a normal flu. So you're getting headache, muscle ache, back pain, low energy you feel and swollen lymph nodes. Okay, all these are the symptoms. Now I already called this particular disease as a zoonotic disease. That means the transmission of this disease from an animal to a human being, this is absolutely possible, right? This is absolutely possible. But if I ask whether human to human transmission is possible or not when it comes to monkeypox disease, the answer is yes. That's what is happening in Africa. Okay, human to human transmission is taking place. Now this might happen because of, first of all, direct contact with the lesions or any body fluid. If you are in touch with that person's body fluid, then you will also get this particular disease. Then respiratory droplets, just like a patient who is suffering from TB, if the respiratory droplets, you also inhale those respiratory droplets, you will also get that disease. Similar thing is going to happen over here. Or contact with contaminated items. So let's say I'm using a handkerchief and that is contaminated with the same virus. You use that, you also get that virus, right? So this is the way human to human transmission is possible. Then sexual transmission. Now this is also confirmed. So by these ways and by this sexual, all these possibilities can lead to transmission of monkeypox virus from one person to the other person. Okay. Now, what about the treatment? Do we have any treatment? Again, the answer is no. That's why it's something we call as a disease of international concern, right? We don't have any specific treatment as such. What we have is just supportive care. Supportive care, I told you in the last lecture. We will just take care of the symptoms. You're getting headache, we'll give you a pill or a drug to take care of your headache. If you're getting fever, we'll give you something like paracetamol, whatever. So this supportive care is just to manage your symptoms. But to deal with that virus, to deal with this disease, we don't have any final cure at this moment with international community. Okay? So this is all about this monkeypox virus. Okay, monkeypox virus, monkeypox disease. Now, zoonotic disease, although I had discussed in the last lecture, but just a brief stuff. Any disease which is getting transmitted from animals to humans is termed as zoonotic disease. And this might involve bacteria, this might involve fungi, this might involve virus, parasites, anything. So any of these can be caused. Means virus can also cause this disease, bacteria can also cause, fungi can also cause. And if I have to give the examples, because of virus, rabies, Ebola, Mpox, bacteria, anthrax, salmonella. So all these are good examples to see. Okay, these are the zoonotic diseases that you get. Now, I said WHO has called monkeypox as public health emergency of international concerns. So how this is happening exactly? So you see, we have this international health regulation brought in the year 2005. Now, what WHO does using this international health regulation of 2005, what they do is, if there is any disease which is spreading in an unusual or unexpected manner, if it is spreading that way, or what we call it as its international spread is possible and there is possibility of a pandemic, or it may cause problem for the entire world, in such cases obviously some international response is needed. That's when WHO comes into picture. Okay, this international health regulation, this thing has come into picture in the 2005, and it's a legally binding agreement. So when you talk about WHO, the members of WHO have signed this particular document, and that's the reason it is legally binding. Under this regulation, we bring in a notification, or WHO brings in a notification. So this PHEIC, this one, it is the highest level alert. When we say WHO is giving this particular alert under this particular international health regulation, that means it is the highest level alert WHO can ever give. Above that, there is no other alert. So this is a red sign which is shown by WHO, which we should know. Now, if you see the diseases till now which have got this red flag or this public health emergency of international concern tag, since 2009, only 7 such diseases have got this particular tag. Which one are those? One is H1N1 influenza, then polio outbreak, Ebola outbreak, Zika pandemic, Ebola outbreak again. Why again? Because here it was in Western Africa, here it was in Congo. Okay. Then the last one was your COVID-19. And the last now which one is added over here is your monkeypox disease, that is mpox. Okay. Try to remember this list, this part. Out of all this, I'll suggest try to remember this fact that is important. Okay. Now, next topic or next article is Parkinson disease. So next topic we are calling it as Parkinson disease. Now most of you must be knowing about this disease because it's a well-known disease, we can say. Recently there was a research. That research has linked mitochondrial dysfunction to this Parkinson disease. Now this linkage is not that important for us. The basic part of this particular disease, that is more important. Okay. So what is this disease exactly? It's a neurodegenerative disease which is caused by death of brain cells. What exactly happens is there are cells in your entire body. There are some special cells in your brains, what we call it as nerve cells, right? Nerve cells, or we even use this term called neurons. Now these nerve cells, when these cells are dying, they are getting damaged. Such a state is a state of neurodegeneration, and this leads to this disease called Parkinson disease. Now obviously if your brain cells are dying, your brain is getting affected, in that case definitely your memory will also get affected. Your ability to think, your ability to solve problems, all those things might get affected. So here you see gradual loss of motor function and cognitive decline. Your cognitive abilities, your motor skills also, that also gets affected because of Parkinson's disease. Okay. Now if you see, it's a majorly known disease. It's the second most common neurodegenerative disease in United States, and it has affected at least 1 million people in United States. So you can understand it's a major disease, it's a major problem. At the world level, 10 million plus. It's a big number. Now, if people ask why this is happening, why brain cells have started dying, is there any cause? Has any bacteria entered or any virus entered because of which your nerve cells have started dying? Because of which you got Parkinson's disease? The answer is no. Scientists are still studying, still trying to research and come to know the real cause behind this disease. But they're still not sure what's the main reason. So, the real reason or the exact cause is unknown. Still, because the research is still going on, they come up with different factors. Some factors they say that there's a possibility of genetic issue. That if you see in the family history, someone must have got this Parkinson disease, then there is a possibility you also might get it. So there is some problem in your genes because of which it might be happening. This is what they say. Some scientists they have come up with this idea that there is possibility of a risk factor because of air pollution, some pesticides, some solvents which are accumulating in your body. Those are causing this problem because of which your brain cells are dying. Okay. Now see, all these are factors, but the real reason, real cause, we are still not sure. Okay, so we have to wait for scientists to come up with that real cause. Now, when a person goes through or is going through this Parkinson disease, what kind of symptoms he will show? So, some tremors, painful muscle contractions. While speaking, there will be some difficulty. And this is the major thing that we observe, high disability rate. Say, when your brain is getting affected, your brain has the major role to play in your entire body. Brain is giving signals. Brain is telling you what to do, what not to do. And when brain cells are affected, now that can lead to disability of any kind. So this disability rate is very high in people suffering from Parkinson disease. And this can even lead to dementia. Dementia means there is a memory loss. You don't have the right memory, you don't even speak the language, you don't understand the language, there is cognitive decline in you. So such a case is possible when it comes to this disease. Now it has been observed till now that such a disease like this Parkinson disease is very much common in people who are age old. So older people, it's very common to see such disease in them. Now, to be more specific, this disease is more common in men than that of females or women. That's very interesting. And this can even affect young adults. Now, this is not something common. Such a thing, such a disease in old people is very common. But in the young adults, it's not very common. But still, we get some cases for sure. What about the treatment? There is no treatment. To be more specific, we don't know the real cause, we don't have the real treatment as such. There is no final cure for this disease. We just use some medicines. We again try to sort out your symptoms. So, some medicine, some surgery, some rehabilitation, everything just to manage your symptoms. There is no cure which scientists or doctors still have with them. Okay, so is there, so let me check if you have any doubts. Okay, no doubts. Now, the next one that we are going to discuss is the Stargardt disease. Okay, you just need to know the basic fact about the Stargardt disease. Okay, it's known as Stargardt disease or also Stargardt macular degeneration. Now, this disease is caused by a specific gene. The name of that gene is ABCA4 gene. Now, when there is some mutation, there is some change. See, the genes or our body continuously evolves, and these genes sometimes change, they mutate. So in case of any mutation in this ABCA4 gene, what happens is it affects the vitamin A metabolism in your body. So you need vitamins, you need vitamin A, and we all know that in case you lack, you have deficiency of vitamin A, in that case there is a possibility of your eye getting affected, your eyesight getting affected. You would not be in a position to see things very clearly. So the same problem happens over here. Although there is problem in this gene, but this affects eyes, both the eyes, not just one single eye, but both the eyes. And this problem is very common in children and young adults. Obviously, it's a genetic problem, it's not being caused by any virus as such. What specifically happens in your eyes, you have something called retina, right? In that retina, something is there that's called as macula. Now, there, this protein gets accumulated, lipophysin, at the central part of this retina. Now, when this gets accumulated over here, the person is not able to see things very clearly. So, there is vision loss in this particular case. So you see these symptoms: gradual central vision loss in both eyes, gray, black or hazy spots in the central region. There is light sensitivity also. People, you must have observed, some people have problem with light. So that light sensitivity will be there, and color vision deficiencies will be there. So all these symptoms you will see in case of this Stargardt disease. Now it's very common in males as compared to females. I'm saying it's very common in males. It affects 1 in 8,000 to 10,000 people. And obviously because visual impairment is there, there will be blindness, and that's the main thing, that there is no cure, there is no solution. We can't bring a person back from this particular stage. That's a major problem. The research is still going on this particular thing. We might come up with any solution maybe in future. Right now we don't have. Okay, so this is your last disease, I would say. You just need to remember this basic part about Stargardt. I'm not discussing in detail about Stargardt because even UPSC will not go in details of this disease. The research is still going on. You should know this basic fact only. What is it affecting? The role of vitamin A. That's it. Okay. Now moving ahead. Now this news is relatively quite important. HPV vaccine. Okay. So what government of India has said that they are planning nationwide HPV vaccination campaign. So they're saying that we'll try to give this HPV vaccination or this vaccine nationwide. So all the women in India, they will be provided with this vaccine. There will be a campaign, just like we have a polio campaign, right? Now, what is this vaccine? Why we are giving it to a person? Now, this vaccine helps a person to prevent one type of cancer. The name of that cancer type is cervical cancer. Now, what is cervical cancer? So, this cervical cancer is possible in women. Now, if you see the reproduction part of a woman, females, in that case, here you see this part called as cervix. So it is part of the uterus named as cervix. And here you see the formation of cancerous cells. What is cancer? You all know. When cells are growing in an uncontrolled manner, they are continuously growing at one place, they're affecting other organs or whatever. That is why we are observing it at cervix. Now, is this a major issue? Is it prevalent in India or globally? Yes. You see, it is the fourth most common cancer in cancer, then we get this as the fourth major reason. And Indian women, if you observe, this is the second most common thing. This is something you need to focus on. That as far as India is concerned, or Indian women are concerned, they're facing cervical cancer as a major problem. Now, there was a recent study published in this Lancet magazine. This study claimed that India accounts for 25% of global cervical cancer deaths. Whatever number of deaths due to cervical cancers taking place in the entire world, one fourth or 25% of those deaths are taking place in India. Okay, now this highlights the issue on the ground. What's the reason? Why relating this cervical cancer? So 99% reason could be one of the virus that is human papillomavirus. In short, we call it as HPV. So I'm saying cancer is called by a virus. The name of the virus is human papillomavirus, HPV. Okay, and this virus gets transmitted from one person to the other because of sexual contact. It gets spread from one person to the other person because of sexual contact. Okay, now that's the reason, because we are concerned about this virus getting entered in your body, and this virus might cause this cervical cancer. That's the reason we are giving a vaccine, HPV vaccine. Okay, now you see India's campaign or India's HPV vaccination program. So it is part of India's universal immunization program. Now under this program, we are giving many vaccines to children, to women, and here HPV vaccine is also given. Now which vaccine to be more specific? The name of the vaccine. So the name is Sarvavac. This is India's indigenous HPV vaccine, I can say. The first indigenous vaccine made by India. Sarvavac was developed by Serum Institute of India. This is quite famous. At the time of COVID, we heard about this Serum Institute. So that's all about HPV. Okay, these are the major facts, these are the major things that you should know, that it causes cervical cancer. Okay, you should know how many people getting affected, or this number, to understand its severity and the vaccination that is being given. Okay, any doubts till now? No? Good. Okay, so let's continue. Now the next article that we have is related to something called ecDNA, or extra chromosomal DNA. So recently this Stanford University has given some study regarding something called ecDNA, and they are saying that because of this extra chromosomal DNA, we might see cancer, growth of cancer in many patients, or even they have observed some drug resistance. Now, more than this study, what is more important for us is, what do we mean by this extra chromosomal DNA? Now, for that, we need to know what is DNA. Okay, I discussed this part earlier too, but just a brief recap of what is DNA. See, whatever information is stored in your body, see, the color of your eye will be black or blue or green, whatever, your hair color, how your hands will get generated, that your body will, from your childhood till now, your height has increased, everything is stored as form of instructions, as form of information or instructions in your genes, or in your DNA. Now when you look at your body, entire body is made up of many cells. If you take one single cell, in that cell there will be a nucleus. In that nucleus there will be something called chromosome, and it's not like there's only one chromosome, there will be total 46 chromosomes in your body, but they are in a paired form. So there will not be one single chromosome at one place, there will be two chromosomes, so there will be a pair of total 23 23 pairs of chromosomes. In total they are 46, right? 23 into 2 is 46. I'm seeing such 46 chromosomes or 23 pairs are there. In the nucleus, this is your cell, this is the nucleus. Okay, in the nucleus, these chromosomes are floating. Okay, now when you look at this chromosome, this one is made up of your DNA. It is bound over there, made up of DNA, or there is a very long chain. DNA is a very long chain, and this long chain is over here. Okay, now I am saying this DNA contains all the genetic information or genetic instruction that you need. Everything is stored over there. Okay, so DNA becomes important. The long form is deoxyribonucleic acid. It carries genetic information for organism development and function. So whatever we have developed into this organism, all that development was because of this genetic information. Whatever we are doing, whatever functions are taking place in our body, if we got a cut over here, that cut gets healed, the blood gets clotted over here. Why this is happening? Because some information is stored in DNA that is telling us, or telling the cells to do this particular task. All this is happening because of deoxyribonucleic acid or DNA, and this DNA is there present in these chromosomes. Clear? Present in the chromosomes. Now we are coming to a new concept, that is extra chromosomal DNA. ecDNA means extra chromosomal DNA. So in the chromosomes, we certainly have DNA, but there are some DNA which are not part of chromosomes. They are present in the nucleus, but they are not part of chromosomes. We are talking about such DNAs. Okay, those are ecDNA or extra chromosomal DNAs. Now, what happens exactly? Some small circular DNA fragments, they get separated from the chromosomes. In chromosomes, this is your chromosomes, let's say. From these chromosomes, some circular DNAs, they will get separated. Very small fragments, some parts we are seeing, they get separated. And now in the nucleus of this cell, they start floating. Very freely they are floating over there. Okay, now why this happens, why they get separated, why exactly? Now the reason could be specifically replication of your DNA. When the DNA makes its copies, DNA replication is taking place. While this replication is happening, let's say some errors take place. Now because of those errors, such fragments will get separated, or because of this something called chromothripsis also. Because of this reason also, this circular small DNA fragments may come out and start floating in the nucleus. Now these are also your DNAs, but they are extra chromosomal DNA. Okay. Now, what is so specific about it? So this extra chromosomal DNA, ecDNA, it was found 50 years ago. But scientists thought this is not so important. It is so rare. They found this case wherein a person is having this ecDNA and all. That was rare, so they didn't give much focus or much attention to it. But later on, it was found that the people who are suffering from cancer, in those cancer cells, 40% of the cases, we saw this ecDNA. The people suffering from brain tumor, 90% of the cases, there we observed that there is ecDNA. So now we are concerned there is some linkage of cancer and this ecDNA, extra chromosomal DNA. Okay, so scientists are still studying, they might come up with few more details on this particular issue. Is this clear? You should just know what is this DNA and what is this extra chromosomal DNA. So if you have any doubts, please ask. Now with this I can say we have completed our this segment is completely done. Now the next one would be your IT and computers part, okay, or IT or communication part. That part we will deal with. Okay, so any technology related to that we will discuss here. Okay, now before I move ahead, please take some time, get refreshed. We'll continue. I'll give you a break of just 1 minute. Okay, take some time, get refreshed. Okay. Okay, so we'll continue. Now we are going to start with a technology called as LIDAR. LIDAR. LIDAR means light detection and ranging technology. This is a news. It's a very interesting technology wherein we are trying to make use of light or laser beam, using which we are trying to map the region, using which we are trying to get all the information about a particular region. So this was in news. Now, when we use this light detection or ranging technique, so it's a remote sensing technology. What we are doing is, let's say this is the region that you want to map, and you want to map this region. What's exactly there? Here you have your building, let's say. Here you have a tree. Here you have some animal, let's say. All that you want to track. You want to track the terrain. You want to track everything that is present over here. Now, instead of taking normal images using your camera, now you can use this LIDAR technology, light detection and ranging. So what you'll do is, let's say you have something over here using which you will send a laser beam. Okay, using this laser beam. So this light is going here. After going here, this light, some part of it will be reflected back. Now this will be calculated. All this information will be calculated by this particular part. So here we might use a satellite, we might use a particular device which can send this laser beam. Okay, normally we're using one device to do this thing. Now when this gets reflected, using this we are going to make a complete map of this region. Now this would be a 2D map or 3D map, but it is going to be a very precise and accurate map. You'll get the exact details. Okay, so that is possible over here using LIDAR. Now how it happens? First of all, we need one laser which is going to emit the light. This is first thing. Then we need a scanner. Now wherever, because it's not like you will just send this laser beam at one place. You have to redirect it to different places, different things, different buildings, trees, everything. So for that you need a scanner which can rotate. Okay, and then you need GPS, which provides the accurate information regarding the coordinates, location exactly. So using all these components, this LIDAR technology is going to work. So you're doing all the mapping part, but what I'm saying is it is a very detailed mapping. Then it is a very precise kind of mapping. The kind of details you're going to get here will be way more different than any other technology. Okay. Now, where do we use this technology? Nowadays, we are trying to use it in aerospace and defense. Whenever we are trying to map a particular region, particular terrain, let's say it's a mountainous terrain or a forest region or anything. Okay, so that mapping part can be done. Then for mine detection, so defense personnel, they are concerned about any mines and all. So if there is a particular mine at a particular location, that can be detected earlier because it's using laser beam, using it will come that there's some problem over here at this particular locality. So that can be detected. Then in any mission planning, any target detection, for that also they'll do that. Then in the automotive part, let's say there's something called advanced driver assistance system. Now, when drivers are getting some kind of assistance through the technology, so they try to make use of different sensors and all. Now, here, when you try to make use of LIDAR technology, your vehicle will easily understand what's exactly there on the road because it's emitting the light is getting reflected. It will understand exact topography, exact terrain, exact particle, exact whether there's a human being, animal, or road, everything will be provided. So autonomous vehicles, for them also this will be very helpful. Then similarly, there will be application in agriculture. So for crop biomass estimation, you want to do the analysis of soil, you want to know the topography of your entire agricultural field, all that can be done. Apart from that, for weather forecasting, for urban planning, so you're trying to plan your cities, you don't know Where are the potholes? Now you can easily know your potholes using this lidar. Okay, and forestry also, environmental monitoring, everything can be done. Now this technology is so important that many countries are competing in the market, have their stand or have their influence in this market, which is working on data technology. Now you see, before 2018, it was United States of America or the companies from United States of America who were dominating this lidar market. But after 2008, China has started dominating. There's a company in China called Hezai. It holds 47% of global lidar market share when we talk about the sales or the revenue part. Half of the segment is controlled by China only, or is one company China only. So you can see the competition for lidar. Okay, that's all about lidar that you need to know. Now, the next technology is Li-Fi, just like Wi-Fi, right? Just like we have Wi-Fi, now we are going to talk about Li-Fi. Wi-Fi is a very emerging kind of technology, and it is being said that whatever communication that is happening in a wireless form. See, there's one way you can get access to internet, you can communicate with people using wired communication. You use wires, and there's other ways wireless. Now, Wi-Fi we all know it's very common nowadays. Everyone is using Wi-Fi. Instead of Wi-Fi, you can use something called Li-Fi, wherein you will try to make use of your visible light. So let's say there is a bulb over here, there's a tube light from which light is getting emitted. This is your visible light. I'm saying we can transmit data, we can send data using the light. This is very interesting. That means if there is one bulb over here that is transmitting data, I don't need any Wi-Fi. The same light will work. I can get internet for my phone, computer, anything. So this is how this technology is being made or will work, is what we are saying. Now see the difference between Wi-Fi and Li-Fi. When it comes to Wi-Fi, which we use, we have one router at home. And that Wi-Fi is provided, the entire building is getting Wi-Fi, let's say. Now here that Wi-Fi is working by making use of radio waves. You see, radio waves are also part of the light. So you see the electromagnetic spectrum from gamma rays, X-rays and all. There are radio waves also, right? And these radio waves, they are obviously the wavelength is very long for radio waves. Now we are using this radio waves for Wi-Fi. The entire technology of Wi-Fi is based on sending radio waves through which this communication is taking place. In case of Li-Fi, we're not using radio waves. We are using the visible light. Okay, so in the electromagnetic spectrum, we have radio waves also, X-ray also, gamma rays also, we have UV rays also, and we have visible light also. So here we are trying to make use of visible light. So we will have some LED bulbs. Using those LED bulbs, we will send visible light, and from that light, this data transmission will take place. Now, why are we even doing this thing? Because if we send data using Li-Fi, the speed of your internet or communication will be way higher than your Wi-Fi. Compare it. From Wi-Fi, the speed that you get is somewhere up to 9.6 Gbps max, not more than that. But if you use Li-Fi, the speed will be somewhere up to 224 Gbps. Now, can you imagine? 200 Gbps. 4 or 5 movies you can download in seconds. And this is the difference. That's the reason we are interested in Li-Fi. Okay? Now you see the range. Now this is where there is a problem with Li-Fi. Range aspect. Wi-Fi has a wide range. If I put a router over here in this room, then a person sitting in the next room also will be able to access this Wi-Fi or these radio waves, because these radio waves, they penetrate from the walls, they go from the walls and they reach out to the next room also, and the range is very wide. But in case of Wi-Fi, it's very limited. So only the area where the light is reaching directly from this LED, only till that location you can get access to internet or to this Wi-Fi technology. Okay, so this is where it becomes bit problematic for us. But there is one good thing also. What is that good thing? You must have heard this thing that you should not use internet or mobile phone in some areas. Let's say in hospitals there are some devices where those devices might get affected, or because of radio waves. So radio waves, let's say you're using Wi-Fi, there are radio waves in the Wi-Fi. Because of those radio waves, some devices in the hospital might get affected. Even the aircraft or the airplanes which you let's say you're boarding a plane, there also you're not getting any internet. So there we can make use of Li-Fi because there is very minimal interference with any electronic product with visible light. Okay, radio waves if you are using, many electronics product might not work properly, there will be some interference. But if you are using visible light, there's hardly any interference that we observe. So we can use Li-Fi very easily in the aircrafts also. Then as far as energy efficiency part is there, then we say Li-Fi is way better than Wi-Fi. Okay, they're taking less energy as compared to Wi-Fi. Name also you should remember, light fidelity. Li-Fi, the long form is light fidelity. You can remember this part. Now, how this Li-Fi exactly work? We said we have a bulb, we have an LED bulb, and this LED bulb is going to emit light. Now, this light will be a modulated light. Okay, some changes will be there. Now there will be an additional chip over here which switches the light on or off. Now how the data transmission takes place. So light will be switched on, switched off, switched on, switched off, and this will be done very fast. You can't even observe. Our eyes cannot even observe that light has been switched on or off because this is being done very fast. And through this, the data is getting transmitted. Okay. Now we have some photo detectors which will capture this light, that it is on, off, all this data that is being captured and it will be sent to the receiver. And we will have some decoders who are going to convert these light signals, light on, off, all these data. They will be converting it into digital data which you can read, okay, which your computer can read. This is how this technology is working. Fine. Now, you should know the application part. So where do we can use this technology, Li-Fi technology? So you can read all this part: indoor navigation, vehicular communication, underwater communication, healthcare, aviation, smart cities. Okay, just think about it. Just look at this and think where all can we use this technology. Okay, sometimes UPSC asks application based questions and you need some brainstorming. You need some brainstorming. So I'll give you few seconds, 10-20 seconds. Just look at the application segment and just try to imagine how we can use this Li-Fi technology. It's very easy. You don't need to, I don't need to even explain this part. Just brainstorm. Okay, so done? Done with the brainstorming? In healthcare, aviation, smart cities, underwater. See, if you're using submarines, their communication, establishing communication is quite difficult. There also you can easily utilize this Li-Fi technology in vehicular communication, in smart cities. When you're saying smart cities, in cities we already have the LEDs, LED bulbs, even the street lights you see. Those street lights can be used to transmit data. How interesting. Okay, so all this is possible. Now the next is 3D printing technology. This technology is also known as additive manufacturing. Why we call it additive manufacturing, and why this specific term 3D printing we are saying. So we are trying to print stuffs. We are trying to, it's not like your Xerox printing or something like that. We're trying to make one product all together using 3D printing. Let's say this pen. I want to make this pen. So using a 3D printer, I can directly make this pen exactly in the most precise manner. So I'll just add the material that is needed and then machine will make it. This is your 3D printing part. Now here we are building a 3D object altogether. When we were doing normal other printing, that was not 3D, that was 2D. Okay, here we are doing it in 3D. Now we use this term additive manufacturing because when we manufacture something, let's say we are making this pen or something, what we do is, let's say some plastic we have taken, then we started cutting the plastic, cutting it in such a way that I can make this pen. So when you're cutting, that means you're subtracting the material. You're not adding any material, you're removing the material. So such thing is subtractive method. So instead of subtracting, we are adding stuff. That's why we call it additive process, or that's why we name it as additive manufacturing. Okay. Now how things are added over here. First of all, a design is made for this 3D object in computers. We use one software called as CAD. This CAD software we use and make a 3D image, a detailed image. That's a very technical task, I would say. And that image is made. Now, after that, something called slicing that takes place. Now, let's say this pen has to be made, okay, or any object, any complicated kind of object. This object has to be made. Let's say. So, the horizontal layers of these objects, if you can imagine, one layer, second layer, third layer, fourth layer, such layers, horizontal layers are made in the computer itself. That process is called as slicing. And after that, the printing work begins. So how the printing takes place, here in this image you can see the horizontal layers which are made by the computer. All those layers are added one after the other, one after the other by this machine. That's how 3D printing takes place. It's not like it is going to cut a material and make it. No. Layer by layer, things are added, materials added. Okay. Okay. And once this printing is done, still we are not in a position to make sophisticated objects sometimes. So we will do some post processing. So we'll remove if there is something to remove, something useless. Okay, we'll do surface finishing and we will assemble. Let's say we have done made different parts. Okay, this is very important. This is going to change many things. Especially, I'll give you one example apart from the aspects mentioned over here. Look at the importance of 3D printing in healthcare segment. You want a particular organ, right? Can you make an organ right now? No. You go for transplantation, you ask for people to please donate liver to me, please donate this organ to me. Now scientists know or doctors know what is the organ made up of, the material needed for the organ. They might be having that material, but they can't make that organ. Now using 3D printing, you can even make one organ. Okay, that's even possible. Or you have to make any technical stuff, any complicated stuff. Making it in the or manufacturing it is a very technical and tedious task, very complicated and complex task. 3D printer can very easily do that. Just provide it that computerized image. Rest it will take care of. Okay, so it's a very important technology, I would say. As far as applications are concerned, in the prototyping part, so you're making the designs, you make a prototype of objects. So for testing purpose we can do it very easily. For customization, as I talked about, this medical implants, any dental device, all this. So there will be application in many fields. Whatever you can imagine, that's possible here. Now the main thing is, what kind of material are we using right now when it comes to 3D printing? So we use plastics. So the examples of those plastics are these one: PLA, nylon, or this ABS. We use metals also, like titanium, aluminium, stainless steel, ceramics also, and there are some composites like the polymer metals. These we are using right now. Okay, this is all about 3D printing. Okay, now apart from 3D printing, we have one more article related to mixed reality. Mixed reality. Now this is related to your VR. Now why it was in news? Because Apple has launched Vision Pro, and here we are making use of mixed reality technology. Now, you must have seen this, and here we use one term called VR, virtual reality. There's one term called AR, augmented reality, and now we are talking about a new term called as MR, mixed reality. Can anyone just tell me what is VR? At least this VR part, virtual reality. What exactly happens in VR technology? Anyone? No? Simply, you start getting some virtual images. This person over here who is using this headset, he is seeing all these images which are completely virtual. This is not reality. So when you're using such headset or something, some device, what you're dealing with is something that is virtual, something that is digital. You're playing a game or whatever, everything is virtual, nothing real as such. Now if we build this technology and ensure that when you're using this headset, you see the entire world also, and you see that virtual aspects also, then it becomes augmented reality. So you see the digital elements also. Let's say there's a technology wherein, let's say, you can use your camera. Using camera, you see a table over here, but on that table, let's say there's a cat sitting. In reality there is no cat, but your mobile is showing one cat on the table. Right now that becomes your augmented reality. The reality, the real objects are there, as well as you have added some digital world things to it. Okay, so when you add virtual reality in real world, it becomes augmented reality. And now when you combine both, then it becomes mixed reality. Okay, mixed reality, a view of the physical world with an overlay of digital elements. Now you'll say, sir, what's the difference? We are not getting it. Simply what happens when you're using augmented reality objects, you just see one layer of this virtual world in this real world. So all these objects you can observe, and in that object some virtual, just like one cat is showing, or you can show some things over there. But in the mixed reality, all these objects, all those virtual objects are interacting with the real objects. Now this is where it becomes really interesting. This is your augmented reality. This will be very interesting. Now there will be applications in many fields, specifically gaming and entertainment. They will be very much useful in education purposes. Let's say I'm teaching on biology, I have to talk about the respiratory tracts and all those things. I can make use of this mixed reality and I show all this very easily. Okay, I can just move my hand and you'll see over here, this blur and all. Everything is possible over here. Okay. Similarly, in design engineering, in the healthcare, in the retail marketing, everywhere, this technology is going to be very helpful. Okay, so this is something very interesting. You will see in next few years. What is Nafis? You must know. So Nafis is nationwide fingerprint database. Now in criminal, you must be having any criminal record, so your fingerprint is there with your police station. Now this is getting added in centralized database at the national level. inform this countries. It is developed by National Crime Records Bureau. They know that if there is a criminal over here at one place, his fingerprint should be available to every law enforcement agency so that they can know about criminals. That data, centralized data, should be there about the fingerprints, right? How does this work? So you give fingerprint, and this is going to stay with you for lifetime. The first two digits are about the state in which this criminal has been registered, and remaining will be the normal sequence. Now, data, CCS, crime and criminal tracking network and systems. Okay, this is already there. It is part of this national level initiative, which is National E-Governance Plan. It's part of this part of it, and here we are trying to build the entire database regarding policing. Okay, so this was launched in the year 2009. All the next one. Next one is your hydrogen. This is used to deal with your microplastics. Now, anyone knows what is microplastic? We know plastic, but what is microplastic? Obviously, it's of micro size, you will say. But what's exactly microplastic? So, we should give plastic particle. Say if it's diameter less than 5 mm, if diameter less than 5 mm, then we call it microplastic. There is microplastic almost everywhere. So, microplastics used many at different places for different reasons. Let's say you're making something like cosmetic products. In those cosmetic products, you're trying to put some microplastics. So nowadays, it's a problematic stuff for us. The first reason is plastic has a problem that it is not biodegradable. Now these microplastics, they are very small, very micro level, and these are also not biodegradable. They do not break down very easily. The major ones, the major or more focused microplastic would be your polyvinyl chloride, which we call as PVC, and PP, that is polypropylene. These are very famous. Now look at this thing. We have a special technology now in the form of hydrogel, which will be used to remove this microplastic. How we can remove this hydrogel, which is developed by IISc researchers, Indian Institute of Science researchers. They have made a special material which is called hydrogel. It looks like a jelly or a jelly material, but actually it is made of three polymers. This and this. Okay, try to remember these names. I know these are very technical and difficult names, but try to remember these. Now these three polymers, using this, they have made this hydrogel. They're saying that if you put this hydrogel, you can easily extract the microplastic present in any region. So you can attract it, so you can absorb microplastics, then you can use UV light to degrade them, to destroy them, and this is how this hydrogel is going to provide very efficient performance to remove all the microplastics. So whether we're talking about oceans, whether we're talking about Himalaya, whether we're talking about all the resources that we are using, wherever we see plastic pollution, especially from microplastic, that will solve the project. So you can even explain one other question, very easy question from this topic. Be ready for that. Okay. Now, next one. Next one is technical textiles. We're talking about technical textiles. Now, what is the news? The recent news is India's annual technical textile exports have been projected to cross 10 billion US dollars by 2030. That means we're doing very, very good when it comes to technical textile. Already India is decent when it comes to textile industry. But in that textile, we're not talking about normal clothes that we wear. We're not talking about that textile. We're talking about something called technical textile in which we are doing such a good work. What do we mean by this technical textile? So some textile materials which we make for a very special purpose, not for aesthetics, not for good looking purpose, nothing like that, but for some special purpose. Best example would be a bulletproof jacket. Okay, when you're making a bulletproof jacket, it's a special textile that is being made. It is technically made. The materials that are added, they are added not for the looks, but to ensure that this jacket or this textile remains bulletproof. So you have to add such things in it. So any textile material used for technical performance rather than aesthetics is a technical one. Technical textile. It's also called as industrial textile, functional textile, performance textile, engineering, invisible, high-tech textile. And what is its speciality? Well, first of all, it has very high physical quality, physical standard, mechanical strength, thermal strength, chemical strength, etc. We use it for many purposes. One, I told you about this bulletproof jacket. Now, there could be some people who are working in the construction workers. They are working in the construction industry, mining, etc. They might be needing some particular jacket or some particular textile. So every person requires, every technical field might require any special kind of technical textile, and that we are building over here. Now to make such technical textile, we make use of fiber. Normal, our textile also, our clothes also, to make that we need fiber, right? So here to make technical textile, we make use of natural fiber also and synthetic fiber also, the fiber that we make in the laboratories. So examples are Nomex, Kevlar, Spandex, Twaron, all these are examples. Now when it comes to these technical textiles, we have divided, classified them in very different categories. If you're using it in agriculture, there is something called agrotech, buildtech, cloth-tech, geotech, home tech, ecotech. Likewise, we have made the classification. Okay, because we're using it in almost every industry right now when it comes to technical textile. Now, you should be aware of this national mission regarding this technical textile. This is one of the reasons why India is doing decent when it comes to export of technical textiles. See, National Technical Textile Mission. It was launched by Ministry of Textiles. This much amount, 1480 crore, this much has been provided. The vision is to make India the global leader in technical textile. We want to top in the exports of technical textiles. And this mission involves four components. One is the research part, because making such thing requires research and development. Then promotion and marketing part, then export promotion, and education, training and skill development. These are the major four components of this mission. Okay, this was all about technical textiles. Clear? Okay. Now the next topic is forever chemicals. How interesting name, forever. Some chemicals which are forever, which are going to stay with you. In short, we also name it as PFX. Now, recently there was a study conducted in Norwegian region. They said that the Arctic ice, specifically the Norwegian Arctic ice, in that ice they are getting forever chemicals, that too in very high quantity. So they are concerned about it. Now, first of all, what do we mean by forever chemicals? Are these chemicals naturally present, or we humans are making these chemicals? So the answer is we humans are making these chemicals. These are completely man-made chemicals, and these chemicals, all the real name is PFA. Now these chemicals we make for some of our purpose. Let's say we are making non-stick cookware, we are making water repellent cloths, we're making some cosmetics, firefighting foams, all these, in all these materials we need these chemicals. Now these chemicals have some speciality. What they do is they resist grease, water or oil. So let's say when we talk about this non-stick cookware, so it is going to repel all these things. That's why it has that ability. So we need those chemicals in these materials. Now why we are calling them forever chemicals? Because first of all, these are made in laboratory. These are synthetic stuff. These are not natural chemicals. And these chemicals, they remain in nature, they remain in environment, and they're not getting degraded as such. So what happens is they start accumulating. They start accumulating in your body, in other organisms also. So these get accumulated in your body, they stay in your body, and that causes lot of many problems for us. That's the issue with these PFAs. So you see, recently it was found in the Arctic ice, and it's not like there's only one PFA, there are many chemicals. 26 types have been found over here. Now when the Arctic ice is melting in the summers, and because of global warming too, it is melting, all these PFAs, all these chemicals, forever chemicals, are going to come out. They're going to become part of our food chain. Okay, somehow we are also going to consume it. The animals are going to consume, plants are going to consume. So from planktons, fish to polar bears, everyone will be affected because of this PFAs. Now what kind of impact will be there on animals or any of these organisms? The fertility will be decreased, the developmental effect will be there, children will not develop rightly, hormonal disruption, cholesterol levels will be increased, some kind of cancer might be there, and it reduces antibody response. See, in our body there are antibodies. In case any virus is attacking us, our antibodies will attack it back because they know that last time we attacked it. Now antibody response might not be seen in a person who is having this PFS in his body. Okay, now you should know that we have something called Stockholm Convention. Under this Stockholm Convention, we have marked some persistent organic pollutants. We are concerned about many persistent organic pollutants. And in this category, these PFAs are also mentioned. So there are three PFAs, this PFOA, PFOS, and PFHS. All these are already categorized in this Stockholm Convention. And that's the reason there is some regulation at the world level when it comes to some of the PFAs, not all PFAs, some of the PFAs are getting regulated. International community is concerned about. Okay, that's all. That's all about this forever chemicals or PFAs. Any doubts? Yeah, if you have any doubts, please ask. Yes, you should actually focus on, first of all, because there will be very basic question asked by UPSC here. So first of all, you should know what is PFAs. Second, you should know why we are calling it forever chemical. You should know this property that it resists grease, water, oil. You should know its application, this part wherever we are using it. This application part you must be aware of. And then you should be knowing about this Stockholm Convention, wherein we have listed some of the PFAs. You should remember the names also. It would be better if you remember the names. These as persistent organic pollutants. So all these which are there in this list, they are very much regulated by international community. Okay, you should know all this part. Clear? Now the next news item is related to glyphosate. Okay, recently it was in news because European Union has renewed the approval for glyphosate for the next 10 years. So there was some regulation and now they have approved the use of this glyphosate. So we should know what is glyphosate. Again, a very basic question, what is the glyphosate? So it's a most widely used herbicide in the world. See, herbicides we use in the agriculture. What happens is, let's say we have started harvesting something. Harvesting is done. Let's say we started with this rice. Okay, so we cultivated rice, we harvested rice. Now, next, if you want to go for any other thing, any other crop, so you don't want some weeds which are present in the agricultural land. You want to remove those agricultures, all those weeds. So you use some herbicides, right? Now the problem with glyphosate is it's very dangerous. It's non-selective. It's not just killing herbs, or it's not just killing those weeds and all. It's killing the plants also. That's a major problem. Okay, that's why many countries are trying to regulate this, the use of this herbicide called glyphosate. Now its scientific name is this one. You can try to remember, at least read it once or twice. Where all it is used in agriculture, mostly it is used in agriculture, but in non-agricultural part also, like in gardens, in public spaces, roadsides, landscape, in all these areas also we try to make use of glyphosate. Now what's the issue? If it is killing plants, that is also fine. The problem comes up when it affects your health. So International Agency for Research on Cancer, they have classified this glyphosate under this category called probably carcinogenic element. So there's a possibility that if this glyphosate is entering your food chain in your human beings, there's a possibility of development of cancers in human beings. So this is something concerning. And obviously you're harming plants also. So there is harm to the environment, harm to other species also who are eating those plants and all. So you're damaging ecosystem, you're damaging your health. So considering all that, countries are trying to regulate it, and recently the news is European Union approve its usage for next 10 years. Okay, now as far as India is concerned, in India we are regulating this glyphosate under Insecticides Act 1968. Okay, now there are 9 glyphosate based formulations which are even approved and allowed in India, but they are permitted in just few areas. For example, in tea gardens, in rubber plantations, and non-crop areas like railway tracks, playgrounds. If you're using there, it is allowed in India. Okay, try to remember this act, try to remember this part where exactly it is allowed. Okay, not allowed in agriculture, obviously. That's all about glyphosate. Very easy? Yes, very easy. Now, the next one is your Bose-Einstein statistics, or it is related to your Bose-Einstein condensate. Before that, if you have any doubts, please ask. No doubts? Fine. Bose-Einstein statistics. You see, we are celebrating 100 years of Bose-Einstein statistics, and for that we honor Satyendranath Bose, okay, for his contribution, especially in the field of quantum mechanics. Now, what is this Bose-Einstein statistic? So it's actually a framework which described many things, and it was described by Satyendranath Bose. Later on, it was extended by Albert Einstein. Now, here we talk about a concept that we call as Bose-Einstein condensate. You should know this concept. Bose-Einstein condensate. Now you see what happens if you take some material which is in solid form. If you give some heat, you will say, sir, it becomes liquid after some time. I'm like, okay. If we give some heat to this liquid, some pressure to it, it becomes gas. And earlier we only knew these three states of matter, that something can exist in solid, liquid, or gaseous form. We didn't understand anything apart from that. Now, later on, with more studies, we got to know if you give it more heat, it becomes plasma. Plasma, what plasma is what we call as the fourth state of matter. But come back, when you're taking away the heat, when you're making it cool, when you're reducing the temperature, so if the temperature of gas is reduced, it becomes liquid. Temperature of liquid is reduced, it becomes solid. What if something which is in solid form, and now you're keeping on reducing the temperature, you're reducing the temperature to absolute zero. Absolute zero, I'm not talking about 0 degree. If you check the temperature in kelvins, then if you reach to this stage wherein we are reaching to 0 Kelvin, 0 Kelvin, or minus 273.15 degrees Celsius. Now this is something we call as absolute zero temperature. And at this temperature range, what will happen to this material? Now it will not remain in solid form. Now what it will become is Bose-Einstein condensate. Okay. Now what exactly happens at this stage? Normally the state of the matter might be changing, but changes happen at the atomic levels. You see, when you see any matter, any material, you say that the smallest unit of this matter is atom, and different atoms are there and different atoms are working over there. Now when something gets to this temperature, here all the atoms will not remain independent. See, in one material there is this atom, this atom, this atom, this atom, this atom. All these will not be independently working. Rather, all these together will act as super atom. Okay, together they will act like super atom. So whatever change is happening, whatever is happening, it's not like something is happening here, something happening. Everything is happening in all the atoms. They together act like one atom. Okay, so this is a very different behavior that we observe in this Bose-Einstein condensate state of matter. And all such particles wherein all this is happening is called as bosons. Okay, particles like photons, gluons, helium-4 atoms. There you observe such phenomena taking place. Now, for the first time, such thing was created in the year 1995 by Eric Cornell and Carl Wieman using rubidium atoms. Okay, this is what we know about this thing, and the framework of this all these things was given by Bose. That's the reason we have named this state of matter with his name Bose, and then Einstein also. Okay, and he provided that framework for it. So this is how I can say we have completed your segment of science and technology. Okay, I'll wait for a few more minutes. If you have any doubts, please ask, or else after that we are going to wrap up the session. Okay, so please ask if you have any doubts. Yes, you can please ask. So I'll just talk about whatever we have done till now. We started all these lectures first with the trend analysis, PYQ analysis, and we understood which sections, which segments get more weightage in the examination. Then we have divided all the news articles in theme-wise manner. We started with the energy technology first, I remember. So energy technology we studied, then we studied nanotechnology. We covered all the articles of nanotechnology. Then we started with biotechnology. Then which one? Space technology we did. Then defense technology we completed. After that we started with the health part, health and this diseases part. Then we completed IT and computers and communication part, and even the miscellaneous segment. Okay, so this is how in a theme wise manner we have tried to cover all the articles. Now it's your job to revise all the stuffs. For the revision purpose, you will get the notes, you will get these PPTs. All these PPTs you can download them directly from the Narana's application. So just download, you'll get the link in the comment box, in the description box also. Just click on the link and download Narana's application. There you will get these PPTs in the free material section. PPTs also, and the compilation also. So if you want to read the entire article, if you're finding it difficult, you can read the entire articles from the compilations also. All those compilations subject wise, they are provided in the free material section. Okay, and in case you still need any help, you can again watch the video again, no issues. Fine. So try to be regular, try to complete all the sections, revise it properly, and just go for the exam. Be confident, and you will crack the prelims if you're confident. Anyway, you have covered substantial stuff. Okay, so that's all I can say. Again, if you have any doubts, please ask. So I'll just wait for one more minute and then I'll wrap up the session. If you have any doubts, you can ask me. So which subject will be started? So next subject, your history part is remaining, art and culture part. That will be done. All these subjects. See, this prelims masterclass is specifically made to revise all this stuff, all the current affairs. So the point is, for all these subjects, one after the other, we are covering. So don't worry, that part will be covered. Next will be history, which will be started on the same timelines. Yes, no more doubts. That's great. So with this, I would like to say that we have completed all the segment of science and technology, and here I would like to wrap up the session. Okay, clear your prelims. After that, we'll meet for your mains preparation. Okay, so thank you so much for watching. Thank you so much.